Hi, everyone. My name is Gian Calisi. I am an industry process consultant from Dassault Systems SolidWorks, and I'm so excited to be the first new host on SolidWorks Live Design. So if you joined us last year, we had a few different hosts. We had Jeremy Regnaris was the main host, but this year we're going to have a few different hosts, just kind of trickling in, and very excited to be here with Brad Williamson, also a senior industry process consultant, right, from Dassault Systems SolidWorks. And
Very senior.
very
Like
more
AARP
than I
senior.
am. So we're gonna go live in a few minutes and get into some cool material. But I don't want to give any of that away yet. I'm sure you can already tell there's going to be a little drumming today. And Brad, you're a drummer as well, right? You're
Yeah.
a professional drummer, actually, right?
Yeah, I'd say part-time professional. I stay really busy. I have over the years, I've been drumming a heck of a lot longer. I've been doing SolidWorks. Let's see, going back to, school band, age 10, I think it was that I started playing drums. Played all through school in just every group I could get into in school and little bands here and there. Played a lot in college. And let's see, about 15 years ago, early 2000s, when I was out in the Midwest, I toured with an original band called Abby Someone. We working hard to try to get a record deal, had a few songs on the radio regionally and a couple national songs that you probably never heard. But did that original band scene for several years and then moved to Nashville in 2006 and have been just working as a freelancer for most of that time.
No better place to do it, huh? Than Nashville.
Yeah. So these days I play a lot of musical theater, and managed to stay busy, probably doing 100 or so performances a year, just about every nights and weekends. That's how I occupy my time.
Great. Yeah. I want to just give a quick shout out to the chat. Any musicians out there, especially any drummers, let us know. And maybe let us know what your favorite song is or your favorite music style. Yeah, I see some comments. So lucky. Yeah, I'm very lucky to be hosting here, especially with Brad, who's a living legend here at SolidWorks. Ray, folks, hey, yeah, I saw you last week. If you joined the live stream last week, it's another live stream series that John Martirano and I host, and we had Jordan Tadich on to do some 3D sculptor. Getting back to basics with SolidWorks Desktop today, though.
Mm-hmm.
Yep. So, Brad, what's your inspiration for music? What are some of your favorite artists or songs? What inspired you to become a drummer?
Oh, that's so easy. That is so easy. I was 6 years old and I bought my first record album with my own money. And I'll bet this is the first album for a lot of people who are maybe close to my age, but it was Kiss Destroyer.
Great album.
Yep. That was my first record. I was in the Kiss Army, at age 6, and it's no doubt about it. Ace Frehley, Peter Criss, those guys are probably the main reason that I just had to become a musician. So they were the early inspiration, but we just always had music in the house. My mom taught piano and organ, so there was a keyboard, and I would always just kind of mess around and learn to read music at an early age, and we just always listened to music, and I think that's probably the sign of a lot of good musicians is that they're good listeners and that they have just a big vocabulary from studying a lot of different kinds of music. Now, I would say probably my favorite drummer of all time is a guy named Jeff Porcaro, who passed away many years ago, but he was a drummer for a band called Toto.
Toto, oh yeah.
Yep. So everybody knows Toto, Africa, Rosanna, some of those songs. What you don't probably know is that the musicians in Toto were all big studio players in LA at the time. So they played on, a majority of the records that came out in the late 70s and 80s in LA. They're mainly the backing band on Michael Jackson's Thriller album.
Really? Wow.
Yeah.
I did not know that.
Yeah.
Oh, nice. Jeremy, Disturbed's rendition of The Sound of Silence. So a lot of rock fans out there, maybe some heavy metal. But Brad, you said you're pretty versatile, right? You're not just rock and roll or just classic rock. You said you like to all types of different types of music, right?
Well, I mean, that's how a musician really stays busy is by being versatile, by learning lots of different styles, by being able to read music. That's probably I'm not a superb drummer, but I can read and I can listen, and that's actually gotten me a lot of jobs. It's not all about the flashiest licks, thank goodness, because I'm not that person. But yeah, having a lot of styles in your vocabulary. I really enjoy listening to jazz. I'm not very good at it, but I practice jazz. I play a lot of musical theater these days, which you could be playing a Latin song in one number, you could be playing a rock song in another number. So you have to kind of be able to fake it in a lot of different areas.
Yeah, no, totally. Hey, Dimitri, just saying hi, guys. Hello from Colombia. Hi, JJ, and hello from Russia. Dimitri's out in Russia. Yeah, we got folks all over the world watching today, but I think it's just about time to get into what we have planned for today. So, Brad, what are you thinking about showing today? Do you?
Yeah. Well, I'm really excited to host this session because it gives me a chance to combine a couple of my passions. All right, so designing in SolidWorks and playing the drums. And what we're going to do today is we're going to unbox. This is one of my new pickups, new piece of gear. It's the Yamaha Flying Dragon bass drum pedal. I think this was designed in the 90s. Really cool design. We're going to imagine what it would be like if you just got a box of parts and you had to put it together. And it's going to allow us to take a look at a lot of really cool assembly tips and tricks, really deep dive into some time-saving enhancements. I think there's a little something for everybody here, from beginner to advanced. And there's just really a lot to like about a piece of gear like this.
Yeah, so Brad, what's some of the engineering going into this? I see a lot of different mechanisms happening that all must work together. Can you explain a little bit about what's going on here?
Yeah, this is a machine designer's delight right here. So the pedal is really it's kind of a modified 3-bar linkage. Okay, so you push on the footboard, about 10 degrees of travel on the footboard here. We'll move this beater maybe about 70 degrees. Okay, so that's interesting. You have this base plate, you have a heel plate, you have the footboard, this main frame where you see this tensioner screw. That's where you get adjustment of how springy and how kind of loose or tight the feel is. And then up in this region here, there's some good stuff happening here. There's a cam. It's a chain drive pedal, you see.
Yeah, that chain.
And then this is the beater. Okay, that's the business end. Bam, boom, boom, like there. Okay.
So you said feel a lot, and it sounds like that's pretty important. Like a lot of things look like they're adjustable in this, so that you can get a different feels with the pedal.
Oh yeah. The feel is well. There's really two things with a bass drum pedal, especially in rock and pop music. This is the critical piece of gear. If this fails, forget it. The bottom drops out of the song, and there's no solution. So it has to be really reliable and smooth, so that you'll find that on a good pedal like this, or my DW pedal that you'll see, there's just no slop in it. It's really well made. And it's built like a tank because it has to work. And then it is all about feel. You want to be able to control the tension. You want the beater angle. You want the footboard angle. It's very, very personal. Even the style of beater that's used. You've got a couple of different styles that you could use for the different feels that you're going for, or different types of music that you're playing.
Nice. Hey, just looking at the chat, just want to give hey Chester, yeah, I see you a lot of these streams. Nice to see you back here again out of the UK. Alban, Janie J, great to see you all here. So Brad, do you think maybe we can get into SolidWorks and see what we're going to start with?
Yeah, we're going to model this thing. Well, actually, I've got it all modeled up. We're going to assemble it. Okay, so I'm not really going to design any components. And by the way, I got to give a shout out to one of our users, Paul Klein. I found this model. He had modeled up this 8210 Yamaha Flying Dragon on a sharing site. I stumbled across it. I chatted him up, and he said, yeah, you'd be welcome to use it. So thanks, Paul, for permission to use your model. His was slightly different from mine. I had to model a couple of these components. I think maybe mine was a little bit newer, or a variation of his design. But for the most part, this is the SolidWorks models you're going to see are courtesy of Paul Klein. So thanks for that.
Great. Actually, Brad, before we get into the software, we're going to do something a little special with this episode, right?
Oh, we have a guest, don't we?
Well, yeah, we do, I think, right? What we want to show that
Is
guest?
it the pedal cam?
I think it might be.
Okay, so we've got the pedal cam making its appearance here for the first time ever on SolidWorks Live Design.
Oh yeah, and some Crocs making an appearance there.
Oh, yeah, you got to have Crocs. You got to have Crocs. And and I also have to shout out my friends at Panama City Beach User Group. They gave me my socks when I came to visit and did a meeting with Kendra and the group down there. So thank you for the drummer socks, Panama City User Group.
Nice. They go great with the Crocs and the drums.
Yeah. And I don't know if you noticed, but I'm in sport mode on the Crocs here. I've got the safety strap engaged, so we don't want any mishaps on set.
So Brad, we're going to do a little bit of drumming in between, in the middle of this demo, right? So
yeah, why not?
Yeah.
So maybe we'll get to a break. We'll do a little name that tune or name that drum solo. Maybe take some. I might take some requests. I don't know.
Yeah. Yeah.
I reserve
any requests out there.
I reserve veto power.
Totally.
Probably a lot I won't know. All right, so let's get into the software and do some basic assembly of the pedal. Okay, so we're going to start from scratch, and I'm just going to open up a brand new assembly document. Now, when you start a new assembly, okay, you're prompted to place the first component. So I'll dig in and search for a part. Now here's the base plate. Okay, that's probably the logical good first component to start with. So I'll drop that in and I'll choose to open that into the default configuration. Now, when you're placing your first component in the assembly, don't get too eager to click here because you don't want to just drop this just anywhere. Instead, go up to the green check and that'll drop that component aligned to the assembly origin. And that's, I think it's a good best practice. You want your initial component to be lined up with the assembly origin, just as a good overall coordinate system frame of reference. And also what I like about this, the base plate was designed with this right center plane. So we're probably going to end up mating a lot of things to that. So I want that lined up with the assembly right plane. And by dropping that in first, you see that it comes in fixed, the letter F in the feature manager tree. So I don't have to put any mates on it, but I know it's not going anywhere. So that's nice. Now let's put in another component. Insert components. This time it's going to be an assembly, and we'll get the frame subassembly. This is where a lot of the mechanical components get assembled. So I'll just drop this in just arbitrarily here in the graphics space, okay? And now we're going to start doing some bottom-up style mating. Whenever I do bottom-up style mating, really what we're going for there is function rather than form. Okay, so we're kind of putting some mechanical behaviors in. Now, the screen tends to get a little cluttered when you're doing these bottom-up mating. So one thing that can really help you here is I'll click on the frame assembly and go to the component preview window here in the pop-up.
That's a great tip.
Yeah, isn't this nice? Yeah, because now you see how I can rotate and position this component basically in its own window. It allows me to be in two places at once, which is really nice. I'm going to do a tab to hide. Just hit the tab key over that screw, and that'll hide that screw temporarily, so I can grab the hole and then control select and grab the hole on the base plate. Now this brings up the Quick Mates toolbar. Probably 90% of my mating I do with Quick Mates, because SolidWorks takes whatever I've selected and it takes a guess and recommends what the best mate would be. Well, it's pre-selected concentric for me, exactly what I want. And it keeps the preview window open, which is really nice. Now I'm going to unhide that screw. But now you see I can do the coincident mate that I need for the bottom of the frame, control select the top of the base plate, and do a coincident mate. And I didn't have to do a bunch of rotating and zooming in and out and stuff that really is, it kind of adds up, that tedious manipulation of the view. This keeps me from having to do a lot of that. Let's go into a top view here. Turn off real view for a second here. Now,
hey, Brad, I got a question for you quick. Sorry to interrupt, but somebody asked in the chat, are you a rusher or a dragger? And I'm not a drummer, so I have no idea what that means. But
I am 100% on the beat all the time. No.
Yeah.
No, probably it depends on the song. Sometimes you tend to rush things. Sometimes you tend to drag it. I play to a click track a lot of times though, so that keeps you very honest. But good question.
Nice. Sorry, I'll let you get back into
No
it.
sweat. No sweat. So it looks like it's in the right orientation, but if I click and drag, just left drag on this, you'll see that it's still free to rotate around. And so I need one more mate at least to lock this orientation down. Now I'm kind of old school in this, but I prefer to go with the simpler mates if possible. So I'm going to take the right plane of the frame and just control select and get the right plane of the assembly. And now from the pop-up, I'm going to choose not coincident this time, but parallel. Because they might not be exactly coincident, but all I want is for them to be in the same orientation. Okay, so that's what that parallel mate does for me. And now you can see fully defined, no minus sign, no F, no plus. It's fully defined. Great.
So Brad, why not make just a concentric mate to the other hole you had there?
Yeah, you could do that as well. I just prefer the simpler mate, the parallel. But the thing about the concentric mate is, what if the holes aren't aligned? Well, luckily, the software has gotten a lot better over the years. You know, years ago, it would have over-constrained if you tried to do that concentric mate. And now there's even an option for misaligned holes that it can make small adjustments to allow for that. So, yeah, that would be a valid way to do it for sure.
Cool. Yeah. So what's next with this assembly?
Next, we need the footboard, which is really going to complete that kind of the skeleton of that 3-bar linkage. Okay, so let's go get the footboard. Another way of getting components into your assembly, one of my favorite tips, the letter R, recent documents. I use this all the time because,
nice.
You know, if you're working in a project, you're probably opening and referencing a lot of the same files over and over again. So you can put them right here in your recent list. You can even thumbtack. So it's always persistent in your recent list. Well, from my recent, I can just drag out that footboard, drop it into view, and now it's free to float around. There's no mates on this. So tip here, if you left drag, that'll translate any degrees of freedom. If you right drag, it'll rotate any degrees of freedom. And I use this a lot of times just to get a little bit closer to my work, to kind of orient it in a little bit closer orientation to what I'm after. So I think a concentric mate here, where these two pins are going to line up, where it's basically a hinge joint back here. So concentric.
Nice.
And then I'll click and drag, and you can see, okay, it's sliding along that axis, and it's rotating with that angular rotation. To get this centered up, yeah, coincident mate, that'd probably work.
Yeah, like right down the two middle planes again, you think?
I think that would work. I want to show you another one, though. This is my favorite mating technique. Might be my favorite SolidWorks feature, period. It's called a width mate. So watch this. I'm going to pick 1, 2, rotate around a little bit, 3, 4, and then the suggestion, there's only one suggestion here for width. Just centered it right up.
Beautiful. And so that adds like a perfect width, so you can get the gap right between those faces too.
Perfectly
Nice.
centered. Perfectly centered. Yeah. So designing for function, that's what we've got here. You know, we've really simulated the mechanical function of the footboard. Of course, this isn't going to work.
Yeah, we must
doesn't
need
have
an angle mate or something. Right.
Yeah. I think an angle mate would be really good. In fact, what we'd want to be able to do is limit the angle. Okay. So to put it through the range of motion. So maybe two appropriate faces, like the underside of the footboard to the base plate. Now, again, I like things that keep me from having to do a lot of zooming and rotating. So I'm going to hit G for magnifying glass. And then I can scroll in with my zoom wheel, grab that face right there, just rotate a tiny bit to control select the top face of the base plate and do not angle, but limit angle. So right from the pop-ups, I can key in a nominal value, a max value, 22 degrees and 12. Now, where did I get those numbers? I just kind of rough measured them on my pedal.
Oh, nice. Oh, hey, Brad, quick question for you. Somebody was just asking if you can edit the recent document list.
Yeah, to an extent. So you can remove items from the recent document. You can control how many items show up in the recent documents. That's a tools option setting. Okay. And then you can thumbtack them. So you get quite a bit of control over what you want to persist in there.
Great. Okay. Perfect.
Yeah. Okay, so here we are I think we're at a pretty good break point, actually. We've designed for some of the basic function. We've got the footboard moving from 12 to 22 degrees. A lot left to do, but maybe another good time to check in on the chat, maybe play a little drums for you. What do you think?
Let's do a name that tune.
Name that tune. Okay. So what are the ground rules of name that tune? Pretty much classic rock. Classic rock from the last 20, 30 years. Something that you probably would have heard on the radio. Okay, so let's do here's one. Let's do this.
Yeah, that's a classic. That's a classic. There is a little bit of a delay here, so I don't want to give it away just yet. We'll give you 10, 15 seconds so the chat can start to answer if they know. But yeah, that's definitely one of my all-time favorite rock bands. So Brad, just checking in at the chat, got a lot of great feedback. People loving this so far. A lot of loving the drums too. Yeah. Oh, Neil said to your when you answered his question about if you're a rusher or a dragger, he said, "Haha, whiplash." Yeah. Is that another drummer term that I'm gonna need to learn?
Whiplash was this movie that came out, I don't know, several years ago. It was about a student who had this really intense instructor, and just really punishing type of instructor, and forced the kid to really challenge himself, challenge his abilities. It's a great movie. There's a lot of really good drumming and great music. So it's all based on jazz. So super fast. I'm not even going to attempt any whiplash. Sorry, no, veto. It's like 300 beats per minute. No.
Oh, nice. Yeah. Neil got it. That was Back in Black by AC/DC.
Yeah. Yeah, if you didn't get it from the first couple of hi-hat clicks, you definitely got it at the end, right?
Yep. Oh, okay.
Yeah. Okay, Neil, I'm going to give you this. This is going to be a harder one, and it'll feature the foot cam. See if anybody can guess this song. This is a 2000s era song.
Okay.
Let's see. That
yeah, that could be a lot of songs. Well, you said 2000s, or else I would say it sounds like Slow Ride to me.
Little Foghat action there.
Yeah, little Foghat.
No, that one was definitely too hard. But what if I did this?
Oh yeah, I think we all know that one.
Yeah, we all know that one. Okay. Let's see. Any requests
another
yet?
one bites the dust. Yeah. Official. Yeah. Official Tej asked for, and I don't know if that was a guess for Back in Black or if it's a request, but
yeah, another one bites the dust is pretty much the same beat as Back in Black, except the four bass drum beats. Okay. Yeah, pretty much the same song.
Nice. Oh yeah, we got so Official Tej is asking if that's from White Stripes, the last song. Yeah, that was a White Stripes song. And then Sofie Rehan wants sorry if I'm mispronouncing your names on here, but Sofie wants We Will Rock You. Oh. Maybe we'll save that for the next one.
Boom, boom. Yeah.
Other than that, I don't see too many questions right now about the SolidWorks design. So whenever you're ready, let's jump back in and
let's pick back up. So next in this next little example here, we're going to study how we're going to get some of these components here on the shaft. We got to get the shaft in here. That's critical. Right. Then all the stuff that goes on that, the beater frame, the cam, all that jazz. So let's start with this shaft. Okay. So once again, I love that recent documents, letter R. Drag in the main shaft, and I'll just plop it out here in space just arbitrarily. And for this one, I could just do concentric mates like before, but I want to show you one of my favorites. It's called smart mates, and it's just like snap to fit behavior. So I'm going to drag, click, and drag. See how that face highlighted? So now the software is looking for other faces that are like that, other cylindrical faces. So if I hover, without dropping the mouse yet, but if I hover over any other cylindrical faces, it's going to try to mate to them. So it'll just snap into place. Now, if it comes in the wrong direction like this, no problem. Before you drop, just hit the tab key. Kaboom. There we go. And we've got a concentric mate looking good. Yeah. And
so what do we think? A coincident mate or something next?
You could go coincident on this if you wanted to. Now I measured this out on the actual pedal, and it's actually a 1 millimeter distance. So how about a distance mate?
Yeah.
So to keep me from having to rotate around to get that skinny little face, there's a little shortcut here. I'm just going to click right in this area and go to select other. That'll let me pick that hidden face right there. Nice. Control, select the face of the frame, and then just do a distance. See how I'm just using these quick mates? They're just natural.
Right. Yeah, I don't even know if I've seen you go up into the toolbars yet.
Yeah, I don't need to a whole lot. Now, the thing I messed up here. This is supposed to be 1 millimeter the other way.
Oh, okay.
So you can edit that mate. You'd go through the feature manager, find that distance mate. But here's a little shortcut. If you just click on that part, you'll see the breadcrumbs that pop up here in the top corner. If I hover over that part, you can see there's the mates that are on that. So it's almost like a slice of the feature manager tree with these breadcrumbs. A slice of breadcrumbs.
I didn't put that together at first.
Okay.
Be ready for those again.
Yeah. So I'm going to take that and flip the dimension, just a right click on that. There we go. So that's looking good. So we got the shaft in place. Nice. Now, the thing is, when you're doing assembly design like this, a lot of times you don't know the structure. You don't know whether something's going to be a part or whether it's part of a subassembly, or maybe it's a subassembly that needs to be just at the top level. You want to be able to control that structure and not be forced into any behaviors. And this is a good example of that. Like this part, this shaft, if you were to buy this replacement, it probably comes as a kit. You know, there's a washer, there's a lock washer, there's a nut. So it's really a subassembly. So to simulate that, I want to replace this shaft, this part. I want to replace it with an assembly. So I'll just click on from the pop-up toolbar, I'll go to Replace Components, and I'll browse out for an assembly. I imagine a lot of you use Replace Component before, but did you know you can replace a part with an assembly?
No, I didn't know that. That's handy, and it'll still, find those common features that it's looking for to try and replace the mates.
Yeah, so that's what it's going to do next. Is it'll take me through all the different mates, and so I'm just going to look through and see. Okay, for this concentric mate, you see how it's missing a reference. It doesn't know what to do with this. So I'm going to click on that mate, try to get a preview of this, and just maybe flip the alignment is all I need to do. Let's see. Yeah, that was all it took. Is it just needed to flip the alignment. And then as I step through the rest of the mates, so the distance mate now is good. So I think what happened is in the assembly of that, it wasn't mated in the same way that the part was. But the software gives me a chance to fix all that stuff when I do the replacement. So now check out the feature manager tree for this. If we look closely, you see that part's been replaced by the subassembly.
Right.
Yeah, and so this idea of organizing your assemblies, you've now got the replace command, you've got the ability to dissolve a subassembly, and you've also got the ability to form a subassembly out of a group of parts at the top level. So you don't have to know your structure going into things, and that's really pretty nice. Yeah, so that's a good stopping point before we dig into the cam and some of those other parts. Is this, Gian, how are we doing in the chat? Do we have some questions?
Yeah, we got a whole side discussion here. Neil's wondering if you could do "Smells Like Teen Spirit" in a little bit.
I don't know how that one goes.
Jeremy says breadcrumbs could be one of the best things in SolidWorks and sliced bread.
2016 was it?
Was that 16? Wow.
I want to say 16.
Neil thinks breadcrumbs is a good band name.
Would be an awesome band name.
Breadcrumbs, yeah, I like it. Looks like one question might not be, well, let's see. It says, can you auto-populate panels by a sketch, not only by a line? that a sketch is made from a few lines. But if you don't know that, Brad, maybe we can see if somebody helping
Auto-populate
us.
from a sketch. I'm not quite
Yeah.
sure I understand the question, but there's certainly ways to pattern with a sketch.
Right.
Maybe that's what they're referring to. And I would invite folks to go back and watch one of the previous live design episodes with Jeremy and Toby Schnars, and they went through all kinds of patterns.
Yeah.
Might
That
answer that question. So take a look at that session.
Yeah, it probably does. And yeah, Alban, if you want to clarify your question too a little bit, you can always rewrite it, and then we'll have our friends on the back end here get the answer for you if not. But yeah, other than that, I think that maybe we are. Oh, Neil's wondering if you can highlight some design considerations that go into the bass pedal design. So I was wondering that too. Like, I don't know, maybe. Yeah, could you expand on that, Brad?
Yeah, I think we'll point some of that stuff out, especially once I get the cam and the beater frame. I'll really be able to point out what makes this design pretty unique. One of the reasons I really like this pedal. So hang on to that question, Neil, because I might add some more color to that in this next little segment. But I want to play another song.
All right, let's do it.
This is one I've listened to a million times, probably air drummed to it in the car a bunch of times, and I've never actually played the song, but I learned a little bit of it. And I think there's going to be some 80s and 90s kids that will know this right from the drum intro. Let's see if I can get it right. Okay.
Okay. Yeah, I don't know if I even know that one. Well, we'll see. We'll see what the chat says. See if they see anything. Oh, so Neil is wondering if things like topology optimization could be applied onto the base plate. Is that something that you'd ever think about using?
Well, I'll tell you what. If I were a drum set equipment manufacturer and I had access to a good 3D printer, I think topology optimization would be really cool because you could optimize that design for weight, for strength, and you would have quick access to get that made. Now, a lot of these components that you see on here, this is pretty old school machine design. It's just cast and machined parts for the most part. It's sheet metal base plate, that's been bent. So you can tell that it's pretty efficiently designed from a manufacturing standpoint. But I think with some of today's tools, yeah, definitely, this would be an area that there could be a lot of room for design optimization.
Great. Yeah, it looks like they all got that. You too, for that last song.
Right. I'm glad.
We got one more question that before we get back into it, and it's is this a double chain or a single chain, and do you have a preference?
Do I have okay, so yeah, this one it's a double chain. So there's two little tiny chain links. Now that's not all pedals are that way. I think my DW that I'm playing down here is also a double chain. Some are single, some are belt drive. Oh, in fact, there's an older Yamaha pedal. You can see this one's a little more light duty, right? It's got doesn't have the thick base plate.
Oh yeah.
This up and throw it in the bag like that.
Right. Yeah, I don't think I've seen one like that.
This is probably a 70s design, but look at the frame. It's the same frame.
Right. Yeah, and they just have like that kind of wire frame instead of the base. Instead of the base plate.
Drive. Okay, same idea. Yeah. Yeah, do I have a preference? Not really, no. And one that I've never played a direct drive, and that's all. The very first pedals were direct drive, is just a mechanical linkage, and it gives like a 1-to-1, totally linear type of feel. I've not ever played one, but those are really coming back into vogue now. I'd be interested to try one out. Neil, if you're a player, are you playing that style? I'd be curious to know if there are any other drummers that are playing those.
Yeah, let's let him see if he has anything to say in the chat about that. Yeah. But maybe we can get back into it. Get that cam on there.
I've got a couple of components that are all going to go together. This frame for the beater, this cam, and then there's a little hub that sits on. So we're going to bring all of those in. I'll use the insert components command for this. And what's cool about this is I can select multiple components at the same time. Control, select 3, all at the same time. And they just get loaded up into kind of a queue. And now I can just place 1, 2, 3. Now let's get zoomed nice and tight on this area here. This hub is centered with the entire assembly. So I want to take care of that first of all before I forget. So I'm going to take the right plane of the hub, go back up to the top of the tree, and get control select the right plane of the assembly, do a coincident mate, just so I know that that's aligned right along the center line of the assembly. Now, this happens all the time where you have multiple parts that all mate to some kind of a common reference. So in our case, like the axis of the shaft, or in my case, it's going to be this outer face of the frame, because I know that face isn't changing. You just saw 2 pedals from one that's probably 30 years old and one that's 10 years old. It's the same frame. This isn't changing. So this is a good common reference. I need to mate all of these parts concentric to that one reference. You've done that before.
Yeah.
Yeah, everybody does that. But did you know you could do it this way? Let's go into the mate command. There's a little paper clip. It's always hiding out over here, and you probably never paid attention to it. It turns on multi-mates. Look at that. Common reference. Okay.
Yeah, I've seen that button there. I've just never clicked it, but that makes so much sense.
So for the common reference, I'll pick the face on the frame, and now I can just go 1, 2, 3, and check mark.
Wow, and that's it?
It's a 3-fer.
The 3-for-1 deal.
3 for 1. Now,
so what about these 2 in the middle?
Yeah.
So it looks like those go together, right?
These 2 go together. Just to clean things up a little bit, let's control select on these 2 components and right click and isolate. Okay, so to center these up, I could do coincident mates. I just love the width mate. Let me do that again. Width mate. So I'll pick 4 faces, 2 from each side. 1, 2, rotate around a little bit. 3, 4. There's the width. It's just so elegant. I just love that command.
Yeah, great. Yeah, for all of you that didn't see in the beginning, Brad says the width mate is his favorite feature in SolidWorks. So if you have a favorite feature, throw it in the chat. Let us know what you like.
Yeah, I'll stand by that. I'll stand by that statement. Okay, so now we've got the cam that's still free to rotate about this hub. And what this adjustment, you can see functionally, you would clamp down on this with an M8 hex screw. Or actually, Yamaha gives you the tool. It's right here on the base plate. See that?
Oh, yeah.
There. You just tighten that down. But what that will do is that allows you to control the angle of the footboard because it's connected to the chain. So the more forward I bring this, the more angle I'll have on my footboard.
I see.
So I'm going to leave that alone for now. Now the frame of this beater, well, this is going to be coincident with the side of the frame of the cam. So that's easy. That's just coincident. And now how do I lock this to the shaft? Okay, well, the shaft, kind of its neutral position is right here, like that with this horizontal. And you'll see, let me tab to hide real quick. Tab key, remember that, to temporarily hide something? See how it's got this hex cut out? And then there's a little set screw under here. That's what physically will clamp it down onto the shaft. Shift tab to bring it back. So I think a parallel mate is what I want here. I'm going to click and then get select other. That gives me that hidden face. Control select parallel. Yeah, there we go. Now, what do we have? We have the beater frame is now keyed with the shaft. So Neil, this is what I really like about this Yamaha pedal in particular, is I can control the beater angle by moving this shaft just a little bit. So if I want more stroke, longer lever arm, more velocity at the head by a longer stroke, I can adjust that this way. And then I can also independently adjust the cam to raise the beater height or to raise the footboard height. I love it. It's so functional. Now, I'm not sure if this is a design element here, Gian, but you notice these little ridges?
Yeah. Is that like where they're supposed to line up?
It might be. I bought this pedal used, so I'm not sure how it comes out of the box, but it just might be that that's like the recommended default position. For me, we look in there close. Let's see. You can see that I'm a little bit off of those ridges. Okay, so I like to have a little more angle on the footboard, so I'll tweak this down just a little. I don't know how much. Is that 1 degree? Is it 3.6 degrees? Don't know. Don't care. I don't want an angle mate here. That would be too rigid, or it would just be overkill. Instead, I just want to lock them together in that position. So that's a lock mate. Quick and dirty. Just take 2 parts and fuse them together wherever they are.
I see. Yeah. That definitely makes sense in this case.
Bang. Okay. Now we've really got that rigid body behavior. Everything's rotating about the shaft the way that you want. Yeah. So we covered some good ground there and really got a chance to look at some interesting features on this particular design. It's cool. There's probably dozens of patents on bass drum pedals from various manufacturers, just because there's so much engineering in a component like this. So neat stuff.
Definitely.
Good time for a break.
Yeah, I think so. A lot of people threw in their favorite feature in the chat for us. A lot of fans of the With Mate. Yeah, Earl Haas says that's his as well. And I saw one before. Yeah, the shortcut menu. Yeah, that's a great one. That's a great one.
Oh, yeah.
Profile Mate is a close second, Earl says, if not evenly matched. Yeah. I don't know. I haven't used the Profile Mate too much myself.
Stay tuned.
Yeah. Oh, it looks like we got some Jeff Piccaro fans.
Yeah.
In the chat here. Yeah, not too many questions right now, so maybe we do another Name That Tune, or if you want to take one of those earlier suggestions. Looks like somebody was asking for the James Bond theme at one point too.
Yeah. That'd be fun to play on guitar too.
Smells Like Teen Spirit. Yeah.
Is Christian Blanc in here? I don't know if Christian was able to make it, but
yeah, I don't see him in here yet.
I've got it. I have this debate with Andrew Gross, who's our producer today. He's a 90s kid. I'm kind of an 80s kid, but we're close. I'm late 80s. He's early 90s. And I always tease him. I think there's probably only like 5 good songs in the 90s.
Oh, wow.
But here's one that I think somebody might know just from the intro. I know Christian Blanc would, because he really likes this band. But let me see if I can play this one correctly.
Okay.
Goes like this. That's the intro of the song. There's nothing else but the drums.
Yeah, that's a tough one. It is tough to name some of these songs just on the drum line, because a lot of them can be pretty similar.
Yeah. Oh, I know one. Here's one everybody will get.
Okay.
I think. At least they'll know the band.
Oh, we just got another suggestion. Race Against the Machine, please.
Oh. Yeah,
but do yours first.
Sorry, Jordan, I do not know Rage Against the Machine. I can't do metal and I can't do prog very well. But here's one I think a lot of people will recognize this band. At least it goes like this.
Yeah, that is my favorite classic rock band. That's some Zeppelin. Yeah, that's some Zeppelin right there. I won't say the name of the song though, if you can guess it in the chat. That's actually probably my favorite song from Zeppelin.
We could probably do a drumming and design just on Led Zeppelin songs.
Oh, totally. Yeah. Easily. Yeah. It looks like somebody was also asking if we're going to do some experimental design with new innovative drum pedals at some point.
Ooh.
Like cool future session.
That would be a whole new future session. And there really are some cool innovations. I've seen people that are doing like an all machined like every single piece machined, no castings, beautiful, almost art pieces. There's pedals that have been made out of all titanium. Very nice. Yeah, there's some really cool innovations in drum pedal design for sure. A customer of ours in the entrepreneur program, Josh Allen. I don't know if you're on the chat, Josh, but Josh, Indie Drums. He left a big drum manufacturer as a designer and started his own company, Indie, INDE. Check his stuff out. He's got some amazing innovations. I've bought some of his equipment too for tom mounts and some other things. He makes his own snare drums, makes his complete drum sets, but really has some cool hardware innovations. So check them out. There's lots of great manufacturers. DW, as I've mentioned, is a customer of ours. Yamaha makes great stuff. Pearl. They all make great equipment. There's a lot of really cool innovations being done.
Yeah, always crazy. So Neil thought it was Cashmere. People knew it was Zeppelin.
Yeah.
Close. Yeah. I'll just give it away. It's When the Levee Breaks.
When the Levee Breaks, right?
Yeah. That is probably my favorite song by Zeppelin. Brings me back to high school football days.
Here's a little one. Another little Zeppelin. Here's one that everybody plays wrong, probably including me. It goes like this. Kind of like that. That's the intro of that one.
Yeah.
Sloppy by me, by the way. So don't hold me to note for note.
Yeah, for all of our drummers online right now, we'll cut you some slack, Brad. But that sounded really good to me. I knew instantly what that is. I don't know if I want to give it away.
You recognize the songs, but you're not sure what they're called a lot of times.
Yeah, that was tough. I wanted to say Whole Lot of Love at first, but I know it's not that.
Yeah.
Rock and roll. Yep, Raphael got it.
Good, thanks, Raphael. That I didn't butcher it too bad.
Neil says John Bonham was a legend.
Yeah.
You know John Bonham? Yeah.
John Bonham, I mean, he was the drummer for Led Zeppelin. Probably any rock drummer, you could trace the influences back, and that's where they go, to John Bonham.
Yeah. Oh yeah. So Brad, I think we're probably ready to get back into Solidworks a little bit.
Yeah.
So what's next?
Okay, so we're going to connect up the business end of this pedal, right? That's the beater. On my Yamaha pedal. Old school felt beater. It just feels so good. There's a lot of mass up here. It's got a little bit of give when it hits the head. I just like it on this pedal. I really like this beater. Other times I'll use these mixed, like on my DW on the pedal cam, you're seeing one of those mixed beaters that's got plastic on one side and felt on the other. But we need to get that into the assembly, obviously. That's probably a critical component. So letter R shortcut. I'll drag my beater in from the shortcut menu or from the recent shortcuts. Okay, what do you think we want to do here?
I would think throw a Concentric Mate, but what about that Smart Mate would be really nice right now, huh?
Perfect for Smart Mates. Just alt drag, and it just snaps into place.
The sound effect helps it work better too, right?
It does. Okay, now here's a little twist on this though. This part's completely axisymmetric. I don't care about the twist. So I'm going to choose this option for lock rotation right here. Boom. And a lot of you probably use lock rotation. I think it was designed for fasteners, right? You don't care about the orientation of the screws, but you don't want underdefined components in your assembly. So that's the trick for that, is you just hit lock rotation on that. Now for the length of the beater here, this really controls where the beater impacts the head. The longer you have there, the more velocity you're going to get. You get a little bit more stroke on that. And it's also a function of the size of your bass drum. My bass drum here is 22 inches. I have an 18, I have a 20. So depending on the size of the bass drum you use, you probably make a small adjustment to the length of the beater. For me, I just measured it. It's about 6 1/8 inch from here to here. So I'm going to do a distance mate on this. And you see I'm in metric, 6 1/8, no big deal. You can always do math in any dimension field, just 6 plus 1 divided by 8, IN for inches. SolidWorks does the math for me. Love it. Good.
Nice.
Yeah.
So Brad, how do you retain that position? Like if you move your drum set or you take it on the road.
Yeah. Yeah, it's a big problem, because typically when you pack up your drum pedal from the gig, you
Mhm.
take the beater out so it fits better in the case more compactly. Piece of tape, a Sharpie. Well, years and years ago, somebody invented what's called a memory lock. And here's one. You see that little guy right there?
Oh yeah, okay.
So it's just like a collar. It's a little
Yeah.
machined collar that lets you hold the position. And there's memory locks. If you look at my drum set, they're all over the place on cymbal stands, on the tom mounts, because they allow you to take stuff apart and then it just snaps right back into the right position. So I've got the memory lock for this one. It's a little machined assembly right here. Just drag and drop that in. And to do the mates on this, let's bring up that component preview again. I hope you liked this when I showed it the first time, because here it is again. I can be in two places at once. So these faces look similar, don't they? Kind of a tombstone type of face.
Yeah.
Hey,
So
Earl
what do you
Haas.
think? A bunch
for
of
you.
coincidence?
No, this is Earl right here.
Oh yeah, that's our Earl's profile, right?
Profile center mate.
That's beautiful. Wait, so is that it though?
Is it?
That's it. All right, yeah. I see why that's your second favorite feature, Earl.
Yeah. Yeah, it just takes the faces and it takes the centroid of the faces and just matches them up. So any
Nice.
polygonal face. Now, there's a lot of variations to that, right? You could rotate that around. It just happened in this case, they just snapped right into the correct position. So now I've got my memory lock in place. I've got, I think if I go to a left view on this, I mean, functionally, we're just about there. We've got this moving the way we want. We've got this moving as a rigid unit. I would do another limit angle on this. I've already demonstrated that, so I think in the interest of time, I'll skip ahead and not put that one in. We'll come back to that in a second. But this is where a limit angle would let you control the range of motion of the beater. But we've got kind of the basic function already figured out. We just don't have them coupled together just yet. So
Right.
we'll deal with that in just a second. But let's pause for a moment, see if there's any questions on what we just covered. I'll let everybody catch their breath after that profile center, because it's pretty epic.
Oh yeah, people really liked that profile mate. So like witchcraft is what somebody said in the chat. And yeah, it looks like we had a request for some Blink 182.
Oh, Blink 182. Yeah, that's you know what? My vocabulary ends at probably the late 90s. So I'm sorry I don't have a Blink 182 for you. And I'm not good at punk drumming. Not in my wheelhouse.
Well, yeah. So Brian said that Led Zeppelin only has 4 albums. Is that true? I feel like that's not true, but it could be. Like, I don't know.
He's hazing us.
Maybe. I don't know my history that well.
Brian, was that Zayas?
Yeah.
He's probably going to request something like from Hamilton too or something.
Yeah. But yeah, I don't think we have too many questions right now. Maybe do a little name that tune.
Oh, okay. Yeah. Here's one from maybe 1979. Very iconic drum part. Let's see if we can play this one. Here it goes.
Yeah, that's I definitely know that one.
Mm-hmm.
I'll let the chat answer on that one. Yeah, a lot of great feedback right now. Oh, so if people like that Blink 182 request, Brad, you might have to broaden your horizon a little bit for next time.
I'll have to learn some Blink 182. Travis Barker, the drummer for Blink 182, monster player. Yeah, for sure.
Neil wants you to play your favorite 90s song.
I did. I think the one I played for Christian. Did anybody get that one? That went like this.
I think I got it back. Yeah, that was the U2 song, right?
Nope, that one.
No, or am I mixing that up?
That one was Toad the Wet Sprocket, a song called "All I Want."
All I Want. Yep. Oh, and they just got the last one, My Sharona,
Yeah, definitely.
Twisted Sister.
Twisted Sister. You know, my cowbell is set up off-site where I'm doing a show tonight. So I do not have the cowbell. That means I can't play We're Not Gonna Take It. I can't play Don't Fear the Reaper, and I can't play American Band. Those are all three really good, recognizable drum songs.
Yeah, great songs. But I think we're ready to get in here. I think people are excited to see how you're going to get your beater and your pedal to match up together.
Yeah,
Think you're ready
John
to
Matrician, you're probably thankful I didn't bring the cowbell, right?
Yeah, he's in there in the chat for sure.
Let's see where we're going to pick up from. So fast forwarding just a little bit, I've added a couple components to this just to speed up some things that we've already kind of shown. You can see now that I've got that limit angle. So we're moving through between 30 and 100 degrees on this angle mate. Yeah, that's dragging pretty nicely.
It is. Yeah, I feel like I've seen those flip themselves before, though.
Yeah, these limit angles can be tricky, and so I don't know the exact answer to this. Maybe somebody does in the chat, but I think what happens is when you cross 90, it's like an inflection point, and it can go undefined because there's multiple solutions when it crosses that quadrant, and I think that's what might cause that flipping. Now this one seems to be behaving okay. My theory on this is that I kept my angle. My reference is to the horizontal. So my angle reference is positive 30 to 100. Okay. Because what would happen if I did something like this, if I had measured it to the vertical like so?
Oh yeah, you'd have like a negative angle one side and a positive on the other.
Right. So it'd be like
that.
60 to minus 10. You know.
Right.
I think that's probably a recipe for Solidworks having trouble with something like that. That's my theory. I think I'm okay on this. We might still see if we're doing a lot of dragging, or sometimes it seems to be how fast you drag it that it can kind of flip through that inflection point. I'm not sure, but at any rate, the problem we have here is we want to couple this motion, and it's not one for one. It's not a gear. It's not a rack and pinion. I don't have a really good mechanical solution for this. To be able to drag both of them at the same time. But there's something that gets me really close. It's a feature called Mate Controller. I don't use it a lot. I think it's a 20-something feature. Maybe somebody knows. Mate Controller. So I'm going to go up to my command search up here and start typing in Mate. Okay, there it is, Mate Controller. And if I touch the eyeball right here, it shows me where that is in the menu. Aha, right there in the insert menu.
Nice.
Look that up.
Yeah, that's definitely my favorite feature is command search. Such a good one.
Oh, yeah. In 2022, we're going to get that in the S key. Ugh.
Oh, let's go. I'm excited for that.
Okay, so with a Mate controller, it's kind of like a mixing board if there's any audio engineers in here, So a mixing board that gives me all these sliders that I can control multiple mates all at one time. So the mates I want to add to this are going to be the footboard angle and the beater angle. I'm just doing two. You could do as many as you want. And it's going to let me capture snapshots along that motion. So position 1, okay, well, that's going to be my resting position where the footboard angle, see these sliders? I get like these little servos. There's the footboard angle and there's the beater angle. So that's position 1, yes. And then I'll add a new position, position 2, maybe this is the impact position, okay? And that's going to be where the footboard is at its minimum position and the beater is maybe at its max position 100.
And Brad, it looks like there's an option to make this part of a configuration too.
Yeah, you can spin out any of these positions. So I can just cycle back to them. So there's position 1, there's the impact position. You can save those out as configs. And there's one other really cool little bonus feature down here. You can key in and have it do an interpolation, like a little keyframe animation for you. Let's see if this works. Ooh, yeah, look at that. That's
great. Oh yeah, that looks great.
Yeah.
So it's not a 1-to-1 though, is it? Because it's like what, 10 degrees to.
Yeah, it's 10 to 7. It's really influenced by that cam. The real mechanical motion is going to be influenced by that cam and the chain. So this is kind of a quasi-dynamic It's pretty good. Now that Mate controller shows up down at the bottom of the feature manager, and then I can just quickly toggle to my various positions. Okay, so position 1, position 2, and then I think what I'll do is I'll right click on this Mate controller, add it to my favorites, and that shows up here now at the top of the feature manager tree, so I can get quick access to it. Nice.
Nice.
Okay, now I got one other thing to show in this little scene before we check back in on the chat, and that is I showed you one thing I like about this pedal. It has this cam that locks down the hoop clamp. It clamps onto the bass drum hoop. You don't want that walking away from you on a gig. Good grief.
Right.
And that has happened before. So anyway, I like the Yamaha design. I want to showcase that. So I've got a display state set up here that hides out some of the components so we can really get nice and tight in on that cam, and a named view here. So you see how this is set up. It's got a limit angle mate.
Oh, yeah.
And so all we have to do, we just have to engage it with this clamp, except my clamp isn't moving. Okay.
Yeah, why is that? Why doesn't it move?
Okay, so the clamp is not moving because it's part of this frame subassembly.
Oh, okay. So it just makes so everything in a subassembly is rigid then?
Yeah, by default, everything's rigid. Because if I were to go into that subassembly, let's take a look at that. Subassembly by itself, you can see it's got the mates set up to where it can move. But when you take that up to the assembly level, well, it's being solved as a rigid body now. And that's generally what you want, because you don't want all those mates being solved at the top level. But what if I did this? What if I just say, just for this one assembly, I just want it to be flexible. You can click over here on the pop-up and go make flexible. Notice that the icon changes just a little bit. It's like a disconnected Lego.
So Brad, why wouldn't you want to do this on just like all of your sub-assemblies?
Seems like you would want to do that, wouldn't you? Why not make everything flexible? Well, basically for performance reasons. On a big assembly, it moves all those mates up to the top level, so they all have to solve at the top level assembly. So that's a performance hit. It's possible that things could go over constrained. General rule of thumb, keep things rigid unless they need to be flexible, and that's what the default behavior is. But in our case, we want this little clip to be flexible, so it's going to be good for our application. Now, I'm going to do a special kind of mate here. I'll go to the mate tools and look under the mechanical mates. Oh, good stuff here. Slot, gear, hinge, rack pinion, screw. Good stuff. Cam. So the cam path, that's going to be this continuous face here on the cam. Has to be tangent continuous. That's the trick. And then the follower is just the small underside. I'll do a select other here. It's the underside of that little clip. Ooh, so nice. It just snapped it right into position. Okay, now watch this. Here's a little pro tip. Who remembers to use these multiple viewports? I'm going to go 2 up right here. Now I can go cam view. I can go hoop view, 2 places at once. I wish I could be 2 places at once. And now you can see both moving. Oh, yeah, that's nice.
So it looks like that's adjustable too with that screw?
Yeah, this is the M8 right here. You just use that tool that Yamaha provides on this one, or pretty common tool for drummers to have something like that. You just screw that down, and that moves that little leaf spring, and that controls the travel on that clamp. Yeah.
I see, yeah.
So we've got one more challenge to tackle. Can we stay for just a couple more minutes?
Yeah, let's do it.
We're at the top of the hour, but I've got that one more challenge. You've been kind of teasing me about how we're going to solve this chain, huh?
Yeah, I've been talking too much too, so putting us behind schedule over here. But I got to see this chain, man. This is the one thing I need to see how you get this done.
Do you have any questions before we go on? Anything I need to answer?
Yeah, well, Mike Sabocek made sure that we know Led Zeppelin has 22 total albums, which sounds a lot. That sounds more right to me.
Yeah, that sounds.
Yeah, I think Brian was just yanking our chain.
He must have been. Oh, chain.
No pun intended.
Okay.
Rob Maldonano's on here.
Hey,
Love
Rob.
your CAD model of the day. Love that stuff.
Okay, who's ever tried to model a chain before? You got all these little links, little tiny pieces, small features, lots of mates. And even if you do get it mated together, it's like trying to herd cats. You know, you can't move stuff. There's just too many degrees of freedom. So I don't really think bottom-up style mating is going to work for these chain links. But there is a really good solution to this, and it involves making a sketch first, using kind of a layout, assembly-based design. Everything up to this point we've been doing with bottom-up style mates. Now I'm going to do something in the context of the assembly. So in advance, I've got this sketch here, this chain sketch. And the trick with this sketch is I made it a fixed length path. So I set it to be a path in the sketch options, and then I just put a dimension on its fixed length. So the entire path is fixed. So that way, when I cycle between, say, the impact position, the rest position, that sketch updates with a fixed length, which is the mechanical representation of the chain.
Right.
So my thought was, what if I could assemble the links to the sketch? That seems plausible, right?
Right.
And then I thought back to, my OG brothers, original gurus, Mark Schneider, Jeremy Regnerus. They showed us a really cool feature years ago. I forget what year it was. It's been a while. It's called chain component pattern.
Oh, seems appropriate.
So with chain component pattern, let me first go to a display state here. That's going to let us really zoom in on that region. Here we go. Let's get nice and tight on that. I'll turn off real view too, so a little easier to see. With chain component pattern, there's a lot of options here. I think maybe we'll dive deeper into this in a future episode, but I'm going to choose the one called connected linkage. Now, what's my path? Well, that's my sketch. So I'll just pick it out of the favorites from the feature manager. I'm going to use this option fill path. That lets the software figure out how many links it's going to take. Now for chain group 1, that's going to be this link. All I'm doing is really instructing the command how to assemble this link to the sketch. So what's the part? Well, it's this part. Chain group 1, that's here. And then I assemble, well, I want the concentric or the axis of this lined up with the sketch. And the other reference is going to be this axis. So it's assembling to the sketch. And then what about widthwise? Like, is it going to be sideways? So I'll turn on my reference planes, little keyboard shortcut for that. So that's going to center that link on the sketch. Okay, now I don't get a preview yet. Why is that? Well, it's because this little preview arrow down here, it's trying to pattern the wrong direction. That's goofy. Let me just flip the direction on the sketch. Oh, yeah, there we go. Look at that. So it thinks that it can take 24 instances of that link. Okay.
All right. What about getting that second one in there,
It's
though?
a double chain, isn't it? It's got links. Okay, so chain group 2, that's this guy, this guy, this guy, and this gal.
Oh, nice. Okay, so now I see both of those.
And if you look up 12, it's 12 pairs. I'm going to set that to static. Yeah, turn off my reference planes. So the chain is the links are assembled to the sketch. And you see how it's free to slide. So you could do chains, you could do conveyors, energy chains, all kinds of cool stuff. Now, for my case, I want this first link to be mated up with the master link. And actually, I've got a mate for that. I just need to unsuppress it. So I'll go to my breadcrumbs for that.
Yeah, those breadcrumbs are such a nice time saver. Imagine trying to find that one mate in the folder, the mates folder.
Okay, so now let's just pull everything back in to the full display state. Hide the sketch. And there we go. That's a beautiful representation of our rest position. And what about if I toggle to the impact position? Okay, look.
Oh,
so
yeah, it didn't update.
Yeah. Okay, there's an explanation for this. Remember, we mixed bottom-up assembly with top-down design.
Right.
So the chain pattern, it's an assembly level feature. It's an in-context feature. So it doesn't get solved until after the mates get solved. So what's the solution for that? You just need an extra rebuild. Just do Control Q, rebuild, and it should. Oh, yeah, look at there. Yeah. It's still 12 links, just like so our design intent is correct here. It's a fixed length chain. It's a number of links, but the shape of the chain changes. And that's what makes this really tricky. That's why I can't really do dynamic motion with this one, is because of the behavior of that chain. But still, it's still, I think, really functional in that, let me pull up a final version of this, just one with all the finishing touches. I think it's still really functional.
Definitely.
Because with those multiple positions, it's kind of quasi-static, don't you think?
Right.
I can get the rest position, the impact position, and anything in between I want with that Mate controller. So this would be good for like a multi-position drawings, or maybe doing some assembly instructions in SolidWorks Composer. There's a lot of really good use cases for even this quasi-static behavior. So I think we've covered a lot of good ground here and showed some pretty eye-opening features that maybe some of the users out here didn't know you could do, or maybe had just forgotten, because we're kind of going back into the archives for some of this stuff. But I really like how the software just let me virtually assemble, my new toy here, or my new maybe it's a new moneymaker for me. We'll see.
Yeah, we'll find out. Because you said you have your first show in a long time is tonight, right?
Yeah. I have a musical I'm playing for that opens tonight. So I've been in rehearsals for that all week, and it's fun to be out back playing live again. Jeepers.
Yeah, finally getting back to normal somewhat.
Yeah. So we went a couple of minutes over there. Sorry about that, folks, for over talking or maybe overplaying. Used to doing that.
No worries. I think everybody has really liked this session. Got a lot of music talk going on in the chat right now. But
Nice.
yeah, not too many questions. Some questions about music. Any A7X fans here? I don't even know if I've heard of them before. It must be a little newer.
I'm not hip to that group. But hey, any music fans out there that are in the SolidWorks community, let me just plug the SolidWorks user community on the 3D Experience platform. Just mention me, just put my name in at Brad Williamson, and chat me up, and I'll be glad to maybe answer questions or talk about gear or anything like that. That's a great forum for us to connect.
Definitely. Yeah, thank you so much, Brad. This was awesome to see you go from start to finish assembling this whole thing. And as always, if you guys liked what you saw, if you guys and gals liked what you saw today, and you want to see more or be, tuned in for the next session, you can always like this video, share it, and subscribe to the YouTube channel. And if you hit that little bell icon, you'll get notified when we have a new video uploaded or a new live stream is put up there for you to sign up for. And just want to talk about next session. So we had a little bit of a schedule change. So usually we've been doing this cadence where, we have the live stream for exploring 3D Experience works every 4 weeks. And then we have SolidWorks Live every 4 weeks with live design in between. But we're doing a little bit of a schedule change because we're going to have a really cool SolidWorks Live session in a few weeks from now. And next week, we're going to do live design once again. So April 15th. And it's going to be Mike Sandy, who's going to be showing how to prep your models for simulation. So from popular demand by you, our audience watching, we're going to make sure that we cover some of those basics and tips and tricks on getting your models ready for assembly. And Michael Steves, who's another simulation whiz, is going to be our host for that live design session. So thank you again, everyone, so much for joining today. This was such a fun session to be a part of. Great talking with you, Brad. Play us off, man. One more song.
Okay, probably the most air drummed song of all time. Here we go. Just fade me out when you're done, guys. Thanks for joining us, and it was really my pleasure to show you that stuff today. But here we go.
Love that. Absolute classic from Phil Collins. See you next time. If you can still see or hear us, we'll see you next time.